All right, let me go ahead and finish up. Notice that it compiled. Actually, if you looked at it, it compiled way quicker than last time. So now what you need to do is you need to actually make all the modules. I probably should have done that as well because that takes a while. So let me get that going. This is going to actually build all the little modules with it. Most of the modules have already been built in the previous one. Oh, looks like they're already done. That's great. So make modules install. This will actually copy all the modules to the correct location. Wow, this is so easy. On your system. Normally that takes a long time as well. And then we'll do make install. This is going to actually create the Linux image and put it into the correct location. Then it's going to make the initRD, which is a temporary file system created when the Linux kernel boots, just in case there's extra device drivers it needs. It's going to put that in the right location. Then it's going to call grub to update the bootloader for you.
I got errors, but then it said found stuff done, so I should be good.
We'll find out when you hit reboot. Then you can reboot the machine. Now, if you select the first option, that's going to boot the kernel that you are in. I just want to show you again, if you go to advanced options, you have the option to go to one of these two. This is awesome in case you messed up on compiling your kernel. But let's go ahead and see if I can boot the kernel I just compiled and if it's going to run perfectly. We'll find out.
Yes, mine worked.
Oh, there we go. The first try. That's a miracle. Okay, now that we have, all right, whose computer made that sound?
It's an evil noise.
I've now lost respect, Chris. Unless you're trying to play a game, then I get it.
I was trying to add sound effects too.
All right, probably should update. All right, install it, and then, just to make sure you're in the correct kernel, when you log back in, you do a uname-a and 4.13.11, which is what we compiled. The old kernel was .9, so we are using our new kernel. All right, now,
Logging is weird again.
Yeah. All right, for this course, make sure you record any problems you had during this process, as they will be part of your grade. I need to know what problems you had, and hopefully tell me, and by hopefully I mean definitely tell me how you fixed them. Also, we want to maintain a small footprint. Creating that .config took a while. So please help me maintain it by keeping it small. Every time they update the kernel, there's always that feature creep. Probably something else that's moved in. If you can take a good look and see if you can disable something. How do I go about doing that? Well, let me show you. If you go into the Linux kernel, do make menu config.
Wait, what?
All right, back into the directory. I'm in the directory where I exploded the kernel.
Yeah,
make menu config. That's going to load up a menu where you can actually select all the different things. Support for paging, yeah, you're going to need that. Probably need System 5, POSIX, enable, yeah, you're going to need a lot of that. You need control group, there's no way getting around that. Networking support. Oh wow, disabled, I got all those stuff disabled. There's probably a couple options in here you can get rid of, although you definitely want to need TCP/IP. Network filtering, net filter, probably don't need the net filter, but you might. SCTP protocol, you probably don't need that one either. There's a lot of things you're going to need to look into about what you can get. Device drivers, block devices. So another thing about, since we're in the virtual machine, you can go look at what devices it is emulating, so you can see which device drivers you can disable. Those that are using VMware, you probably need to go in here and enable different device drivers to make those things work. Just FYI, when you go and compile that, make sure you record that and tell me what you need to enable. That'll count as well. I just want feedback from you to help improve this .config, because this took a while.
So, when we disable those things, is that going to disable them the next time we reboot it, or do we have to make the whole thing?
You have to, once you disable it, like right here, I know for a fact we don't need extension 3. You disable it, then you go and you save it, you recompile the kernel, all the modules, install, and then reboot. So I just did this. Let me show you. Exit, save. What I would do is I would create a doit.sh, because this is always my favorite shell commands. Oh, I don't have Vim, so let me go ahead and install Vim.
I was questioning that.
Then I'll do Vim doit.sh, and I'll just have it do make -j2 and make modules and make modules install and make install. And let me make sure I make
So that's all the command things we're hearing before.
right.
Just
And doing the and means don't do the next one until the previous one succeeds. The previous one fails, exit out. Just a nice little shorthand. When you get out here, change mod plus X, the do it script, and then when you do it, it's going to run all that. And I'm going to control C this because I don't want to watch myself recompiling the whole kernel right now.
So disable the things you disabled.
Record what you disabled, and then try and recompile and see if you can boot back into it. Because if you can't boot back into it, you obviously needed it.
Disable everything.
All right, now to create your own system call. Well, at least I'm going to go through and point out what you need to get done. I'm not going to do it for you. I think once you get the kernel compiling in an environment, actually I highly suggest once you get it running and you can boot into it, close down the virtual machine, copy the virtual disk image to another location in case you mess up, and then go back and start from here, because sometimes all of this can take a while to get right if you've been having issues. And wow, there's a lot of question marks that need to be fixed up here. Okay. So in order to add your own system call to the Linux kernel, you first need to declare it. And we're using x86. If someone's using something else, you're going to need to talk to me about it. It'll be in a different location. You'll probably have to research that. But it's not too hard. At least I hope not. What have x86 entry syscall 64. Yeah, so we're going to go x86. I did not type that in.
Dumb question. This is still the
Arch.
64-bit one though, right? Okay.
Even though 64-bit is in x86.
Okay.
Because you still support the old 32-bit system calls. And I can never remember entry syscalls. That sounds great. Entry syscalls syscall_64.tbl. All right, here are the see like read, write, open, close, stat, fstat, pull, etc., etc. Schmimget. When you create your own, make sure it's part of the first section. So it should be at what, 300 and something? 332. Don't make it for the second one. Make it up here. Right up here, 333. I used a tab. Make sure you make a tab. Call it something like your name. Don't call it Dr. West. That'll be a 0. And when you're over here on the right, it does need to be sys Dr. West. I wrote this in the instructions.
Dr. West 1.
Dr. West 1. You can exit that. And that declares that this system call should exist inside the Linux kernel. Next, you're going to need to actually implement it. And where do I recommend you do it? There's many locations, and we're going to just put in kernel/sys. That sounds great. Let's see. You can see there's a lot of system. Oh, there we go. There's system define 2. There's define 1. That sounds awesome. Let's just steal that. Call it Dr. West. Will be passed in character, and it'll be called message. One weird thing is there needs to be a comma right here. That's just how it's done.
Comma where?
After the char star, normally it would be like this.
Okay.
You need the comma.
Yeah, that's weird.
That is weird. Just get used to it. The define 1 means you have one parameter, aka message, but you could also have define 2, which would have 2 parameters. Well, now,
Define 3.
how many parameters would you have?
4. That sounds right.
Copy and paste this code. It'll go and print something out. I'm not going to do that right now. You can recompile your kernel and install it. If you have errors, fix it. So here's where I do my little do it script. And it would start compiling everything. And here's a piece of code to directly call your system call from C. GNU source sys/syscall.h. When you update the kernel and you compile everything, it's going to update this header file inside of GCC for you. I defined the syscall as 333. That's what it was in this one. And it should be the same in yours since we're all going to be downloading the same kernel. I'm just making sure you provide a string, and then I'm going to call the system call Dr. West, passing in whatever you passed in. And it's going to call the code up there, but inside the kernel space.
Spooky.
And then afterwards, it's going to say syscall return. Now, this is how you compile it. There should be a new line right there. Make sure you take a screenshot of it running so I can see that you actually did something and didn't copy everything from someone else. Next, do a demessage, and that should print out a debug message from the kernel. At the end, it should be this little message that's up here. Dr. West syscalled from etc. etc.
Except not Dr. West.
Yeah, it should be something else. Make sure you
Corky Snuggles.
That sounds amazing. And take a screenshot of that and send it to me. Let's see, did that actually compile? Looks like it's compiling, great. Okay,
But you didn't make your system call, did you?
I made it, I just have it return success.
You haven't compiled it with it. You
No,
just
that's what-
compiled it with the things you disabled, right?
So what I did before I compiled, oh, I need power. Don't have the power.
Oh, class is canceled.
Oh no! So what I did is I declared the system call in that system call table. Then I wrote at least a header code inside of the kernel itself, and there's kernel/sys.c. And then now that I'm recompiling the entire